In the section How Do I Multiply Polynomials, there is a word problem to test your ability to interpret a word problem and use the skills we just practiced on the left column. Here is our word problem. I'm going to scroll over to this one. Sally has a photo which is 20 centimeters tall and 32 centimeters wide. She wants to put a frame around the photo which is the same width all the way around. What is the expression for the area of the framed photo? So a couple things I want to note here. We got a photo. It's got height and width. So again, class, I would recommend you go ahead and make a diagram. Let's make this one relatively big now because I'm going to label some things for you. So I'm going to make a photo here. And then she wants to put a frame around the photo, which is the same width all the way around. Let's go ahead and put a big frame around this photo. Okay, so there's what we have so far. Let's label some things. The photo itself is 20 centimeters tall and 32 centimeters wide. Now, to make this diagram a little more readable, I'm going to actually write those dimensions on the inside of the photo. So for our photo here, let's say this is 32, and I'm not going to write centimeters because everything we're doing is going to be in centimeters. And I'm going to say that the height of this one, or how tall it is 20. So there's our dimensions of our photo. So we've covered this part. She wants to put a frame around the photo. We did that, which is the same width all the way around. That, class, we don't know what that is, but we're going to have to assign it a variable. Let's just call that x. So when they give you something about the word problem that you're supposed to figure out, but they don't tell you what the value is, you assign it a variable. We don't need a variable for the width and the height of the photo because we know those dimensions. So now here's the weird part. How do you diagram this? So what you do is you're going to say, okay, the width of this frame from the photo to the end is x. Well, it says it's the same width all the way around. That means this width is also x. And we could also say that this width is x. And same thing on this side. This width is x. So everywhere around this picture, we've got a frame that has a dimension or a width that is x centimeters wide. What we're trying to answer now is, what is the expression? Remember, an expression doesn't have an equal sign. It's just a math sentence. You can see over here, these are all expressions that we did. We got to find the expression that represents the area of the framed photo. Now here's the important part. When it says the area of the framed photo, that is the whole thing. If they asked us what the area of the photo is, oh, it's just 30 times 20. It's area equals length times width, 30 times 20, you're done. We want the whole thing. We want the photo and the frame. Okay? So I'm going to show you a little trick here, something you can think of when you look at these dimensions, because all we need to know is the area of this whole big rectangle. If we know the area of this whole big rectangle, that is the frame and the photo put together. So I have to know the dimension of this side, and I have to know the dimension of this side. I need to know the length and the width of the bigger rectangle, the outside of the frame. And the way you look at this, class, take a look. If I want to know how far it is from here to here, well, I know this part from here to here is 32. Because that's the dimension of our photo. And I know the length from the corner of the photo to the outside of the frame is just x. And I know the corner of this photo to the frame is also x. So you can see that to find the dimensions, I'm going to draw this a little bit different. To find the dimensions of the bottom frame, I'm going to put it right here so you see this line right here. It's just x plus 32 plus x. And we can simplify that. That's 32 plus, how many x's do we have? We got 1, 2 x's. That's 32 plus 2x. You've learned how to add monomials. These are like terms, the x terms. That's 1x plus 1x, which is just 2x's. So there's our dimension for the bottom, or the length of our frame. We can do the height of our frame the exact same way. Take a look at this. If you want to know how far it is from here to here, we know that this part right in the middle is the same as the height of our frame, of our picture, which is 20. And we know this length right here is x. That's the width of our frame, and this is also x. So when you look at this, the width of the whole, or the height of the whole thing, is x plus 20 plus x. And that's just 20 plus x, which is 20 plus 2x. Again, we know how to do that because we already know how to add monomials together. Well, you just really took care of the difficult part of this question, finding the actual expression for the height of this whole frame and the width of this whole frame. All we have to do now is put those together, because we know that the area of the whole thing is going to be the length of the whole thing times the width of the whole thing. Again, class, you can pick either one of these to be length or width. It doesn't matter because we multiply them together, and multiplication is commutative. You can put this binomial first, this one second, or this one first and this one second. I'm going to go ahead and put this one first. So there's our first expression for the length, 20 plus 2x. And then this is going to be our width, which is 32 plus 2x. So now all you have to do is multiply two binomials. Good news is we've already learned how to do this. You're going to take the entire second binomial. You're going to multiply the first term of the first binomial by that, and the second term of the first binomial by that. So now we're going to have 20 times 32 plus 2x. And then we've got positive 2x, which is right here, times the whole second binomial, 32 plus 2x. There we go. We're getting close. Let's go and multiply this out. All right, we got to multiply a monomial times a binomial, 20 times 32. Sorry, class, I cannot do that in my head. So 20 times 32 equals 640. So this is 640 plus 20 times 2 I can do. That's 40, and there's only one variable, x, so just write x. Then you've got 2x times 32. 2 times 32 is 64. X times nothing, there's no variable there, just as x. And then 2x times 2x, well, this is just 2 times 2 is 4. X times x is x to the 1 plus 1, which is x squared. So we're getting close. Let's take a look for like terms. This is a constant. There's no other constant. We got an x variable and an x variable. Those are like terms. You can combine those together. And then we have an x squared by itself. Cannot be combined. Now, I'm going to do one more thing in this particular problem, class. I'm going to go ahead and put the terms in proper order. We'll learn this in a different video. You want to put the term with the highest exponent first. So we got 4x squared. Our next exponent is x to the first power. This is 40x plus 64. Let's do 40 plus 64 is equal to 104. Plus 104x, because those are like terms. And then we have our constant at the end, 640. 4x squared plus 104x plus 640. Now, you might have the temptation to write a equals this, but here's the problem with that. It's a small problem, but it is a problem. It asks you for the expression, not the equation for the area of the frame. But if they ask you for the equation, your final answer would be a equals 4x squared plus 104x plus 640, because that's an equation. It has the equal sign. They want the expression, so we're actually done right here. The expression, remember, an expression is a mass sentence but doesn't have an equal sign in it. So there is the expression for the area of this frame and photo combined together. Hope that made sense for you. I know I went through it in detail. You'll see lots of problems, class, that set up the exact same way. They'll give you a swimming pool with a walkway that has the same width all the way around, a picture with a frame with a walkway all the way around, a garden with a pathway all the way around the same. All of these are drawn and measured, figured out the exact same way.